Today, we're jumping right into one of the most exciting parts of cybersecurity, Linux privilege escalation. This isn't just some abstract technique, it's the absolute game changer that takes an attacker from being a simple visitor on a system to being its all-powerful master.
So, picture this. You did it. You found a vulnerability. You launched your exploit, and you're in. You have a shell, a little command prompt blinking at you from a server somewhere out there. But you're just a nobody, a low-level user. You can look around, but you can't really do anything. This is where the real work, and honestly, the real fun is about to start. Your mission, should you choose to accept it, is to become root. In the world of Linux, root is basically God mode. It gives you total, absolute, do anything you want control. And the process of getting from your weak user account to that all-powerful root account, well, that's what we call privilege escalation, or privesc for short.
Okay, first things first. Before you can even think about attacking, you have to know where you are. Your very first commands are going to be your eyes and ears. Stuff like "Who am I?" tells you who the system thinks you are. ID tells you what groups you're part of. And uname -a, that one can give you a crucial piece of the puzzle, the system's kernel version. So now we're just gathering a little more intel, getting the lay of the land. You know, what operating system are we on? What's the server's name? But let's go back to that kernel version for a second. If you see that it's old and hasn't been updated in a while, your eyes should light up. That is a massive, flashing sign that you might have just found a fast-track ticket straight to root. All right, our basic recon is done. Now the real investigation begins. We're going to start actively poking around, hunting for sloppy mistakes and security holes, those little misconfigurations that we can use to grab control of the whole system.
First up on our checklist is sudo. The command sudo-l is our first real probe. It's basically us asking the system, hey, is my current user account allowed to run any commands as someone else, especially as root? If the answer is yes, even for one simple command, well, we've just found our way in.
And check out how easy this can be. Let's say sudo-l tells you that you can run the text editor vim as root. I mean, that sounds harmless, right? It's just a text editor. But nope. You run it, and from right inside vim, you can use a special command to pop open a new shell. And boom. Just like that, you're root. Game over. Next up, we're hunting for something called suid binaries. Now, these are really interesting. See, normally when you run a program, it runs with your permissions. But if a program has this special suid bit set, it runs with the permissions of whoever owns the file. So if a program is owned by root and has that suid bit, it runs as root no matter who started it. It's a huge potential backdoor, and this find command helps us track them all down. So our goal is to find one of these suid programs that we can abuse. And here's the beautifully ironic part. Sometimes the very find command we use to search for them is the vulnerability itself. If find happens to have that suid bit, you can use it to execute a shell just like you see here, and bam, you've got an instant root shell.
But the hunt doesn't stop there. We've got more clues to look for. Are there any scheduled tasks, we call them cron jobs, that run as root but that our lowly user can actually edit? If so, we can just slip our own malicious command in there. Or what about path hijacking? This one is super clever. The path variable tells the system where to find commands. If we can trick it into looking in a directory we control first, we can create a fake version of a common program. The next time the root user runs it, they're actually running our code. Every single one of these is another potential doorway to full control.
So, we've looked at all these different tactics, sudo, suid, cron jobs, but how do you actually put it all together in a real-world scenario? Let's talk strategy, because a real attack isn't just randomly trying things, it's a methodical process. This right here is the typical pen tester's workflow. It's a step-by-step playbook. You get your shell, then you enumerate. That's just our fancy word for doing reconnaissance. After that, you systematically work your way down the checklist of the most common vulnerabilities. Sudo, suid, weak file permissions. And only after you've done your homework do you try to strike. That's what separates the pros from the amateurs. Now, doing all of this digging manually is the best way to learn for sure. But when you're on a real engagement, time is money. That's when you bring in the automated tools and, of course, the last resorts. Tools like linps or linenum are basically your own personal robot assistant. You just upload one of these scripts, run it, and it'll tear through the system looking for hundreds of possible vulnerabilities. It then spits out a color-coded report highlighting the most promising ways in. It can save you literally hours of tedious manual work.
But what if you've tried everything and the system is actually locked down pretty well? Well, then it's time to go back to that kernel version we found way back at the beginning. If it's old, we might be able to attack the kernel itself. This is the nuclear option. It's high risk but high reward. You use a tool like searchsploit to find a public exploit, you run it, and it can give you instant root, or, it could just crash the entire server. No guts, no glory, right?
Okay, we've been on the attack this whole time. Let's switch gears. Let's put on our blue team hats. How do you, as a sysadmin or a defender, actually stop all the things we just talked about?
As you might guess, the best defense is basically just doing the opposite of what we did to attack. You lock down sudo so it only allows what's absolutely necessary. You get rid of those risky UID permissions. You patch your kernel religiously. You secure your file permissions. It all comes down to proactive security and the principle of least privilege. Don't give anyone more power than they absolutely need.
And hey, for anyone out there just getting started in this field, listen up. It is so tempting to just download some script off the internet and run it without knowing what it does. Don't do that. The real skill, the thing that gets you hired, is understanding why an exploit works. Master the manual enumeration, really understand the fundamentals, and you'll be light years ahead of everyone else.
So, after all of that, the commands, the exploits, the defensive tips, what's the one big idea that I really want you to take away from all this?
You have to remember this. Getting that initial shell is just kicking the door open. That's step one. Privilege escalation is what lets you walk in and completely take over the entire house. It's the critical step that turns a minor security incident into a full-blown catastrophic system compromise.